Hey everyone, I wanted to give a sneak peek of the tutorial series and everything. So I'm going to just dive on into it. For those that don't know, I've been working on a tutorial series for a year now, literally a year. And we're actually getting ready to start releasing it. It goes over how to create your own physics 2D core components using the new physics shape physics body API, how to do burst compilation, how to do multithreading. It's going to be intermediate to advanced, basically help you write your own custom physics stuff. For example, this project has 0 object colliders or like rigid bodies on the game objects as well. It's all custom physics component, and some of them don't even have a component and still have physics. Do you know this is not entity components? This is just normal Unity like game object structure. But this tutorial series, we're going to be going over how to do stuff like a vampire survivor system. So we actually have like custom physics debugging using Unity's physics core 2D API debugger and world drawer. We're going to be creating our own little spawn controller system, just like Vampire Survivor. And as you see, like we can actually do like a projectile system. We are also going to be doing a combat ability system, not just like normal, like just shoot a projectile and stuff like that. We're also going to be doing something like this. So if I actually zoom in on my character here, as I walk, you'll notice that I now have like a little like a thorn and stuff that actually spawn behind me. So we're going to be doing like a ability like system where you can actually like spawn stuff as you like walk, and you'll notice that we have like a little circle that appears around the player. So it's actually a protective barrier that actually damages and slows enemies when it's active, and it goes on and off. So we're going to also be showing how to create a custom status effect system, and also how to create a custom like timer system for like hitbox duration and so forth. If anybody's ever played like Vampire Survivors, you might know the garlic ability. Yeah, that is actually what it is. It's just a garlic ability. But yeah. And what we're going to be using is burst compilation, and I'm also going to show how to do this in CoreCLR. Like this project actually builds to CoreCLR. So reason why? Well, I want to show you guys how to get good performance. How good performance are we talking about? Oh, we can just spawn a lot. 100,000, 131,000 enemies. Do note in build I can get up to 2.2 million. The reason why build is so much more, Unity doesn't have CoreCLR support inside the editor, but it has CoreCLR support inside player builds for 6.7 alpha 2. So if I actually make a build and target actually like CoreCLR, the performance jumps. So you can actually get into the millions with this. And as you see, like I have a poor like just enemy, or sorry, the player's like in the center here, and you'll see just enemies are pouring to him. But yeah, and if anybody's wondering like, okay, that's pretty cool, I'm also going to show you kind of like foundation stuff. Like for example, what if I said adding a single 1 to how many enemies you spawn can half your performance? So here we go. Let's actually go here. I'm going to actually disable this one, and I'm going to enable this one. So if you see here, we have a like a spawn count, and that spawn count is literally 32,768. So if I actually click play, I'm going to actually show let's actually go show the stats menu here. I'm going to pause so you guys don't have to like burn your eyes. If you notice, like when I'm paused, we got about 50 frames, 60 frames. Again, editor is going to be slower than CoreCLR builds, so about 60ish frames. But watch what happens when I add a single one. So we went from 68 to 69, right? I just added one more to spawn. Watch the frame rate. It halves. So we're going to be going over why that actually happens, and why using the power of 2, like spawning enemies in powers of 2, not just in Unity, like this is also C#, like most programming languages, if you are actually using powers of 2 in certain variables, you can literally quad your performance on stuff. So we're actually going to be not just like teaching game dev stuff, we're going to be talking about like actual like performance things, like how stuff works on CPU. We're going to be talking about some native code and so forth. So yeah, literally just adding one, like a single one that's already spawning tens of thousands, can literally have your performance. We'll talk about that. And if you also notice, there's no game object spawning. These are not game objects. We're going to be teaching you how to render custom GPU commands and actually sync physics to the rendered sprites. So if you notice, those rendered sprites are still moving, even though I don't have any game objects or any components. So we'll also be showing how to use transform access array to actually use a IJobForParallelForTransform to actually multi-thread and calculate where the sprite should be rendered by the GPU, while also having physics events synced to that GPU command. Yes, we're actually going to be using a GPU command with physics syncing events. I'm going to be showing off how to do that, but we're also going to be using just normal game objects. I'm going to show both of them. So for like this example, the spawn wave controller, you'll notice that game objects are actually spawned. I'm going to be showing both ways, and the reason why I want people to know the benefits of both ways and the downsides, because each way has benefits, each way has downsides. If anybody's wondering, like with the game object way, how many game objects can I spawn at once without a frame drop? Thousands, tens of thousands. Not just like a game object with a transform and sprite render, but you can also spawn like with physics stuff. Like if I actually like click here and click on one enemy, you'll notice that they have like a custom. We're going to be learning how to create custom physics components, as I mentioned, XP scripts and like loot drop system, stuff like that. But we're going to be actually using code that not a lot of people know about. There's this thing called game object instantiate game objects, and it actually takes an entity ID and it spits out native arrays. So this tutorial series is not just going to be like your basics. This is going to be intermediate and advanced. We're going to be going over entity ID, how to use it to spawn a crap ton of stuff. We're going to learn how to take that entity ID and actually convert it to a usable component or game object. So for example, the instantiate game objects command, you take in the entity ID of the prefab you want to spawn, how many you want to spawn, and it actually spits out and fills two pre-allocated native arrays. The first one it spits out is the allocated array of game object entity IDs, and then the second one is the allocated transform entity IDs. So we'll be going over how to do that and how to actually inject it into, as I mentioned before, a transform access array. We're going to be going over a lot of other stuff. By the way, there's over 100,000 lines of code for the entire tutorial series. I'm going to be cleaning that up. It's probably going to be more closer to 70,000 lines. That's because I'm also going to be showing source generators, how we're going to be using Roslyn system to create a modular RPG stat system, and so many more things. Like, we're not going to just be making a Vampire Survivor-like game. We're also going to be doing a Metroidvania. So if I actually go here, I can actually show this off. I'm going to say, don't save. As you see, I actually have a Metroidvania game, and we can actually do abilities. We can glide. We have custom hitbox system, custom ability system, AI patrolling, room modules, saving, and a lot more. So we're also going to be doing a Metroidvania series and a top-down ARPG series that's closer to like Legend of Zelda. So and ignore the UI. I update Unity and I have to like update a UXML schema reference. So UI is a little messed up, but that's okay. It's literally just a one-click button. But yeah, we're also going to be going over how to create databases and actually preloading them. So we're actually going to learn how to create an inventory database, loot database, and dialog database, stuff like that. We're going to be talking about AES encryption and how to actually do them inside your player builds, but not do it inside editor build. That way you can actually like debug your saves in editor. And for anybody that doesn't know, AES is you can use an AES instance to encrypt and vector, like using like vectorized data. So your save files will actually be encrypted, so people can't like edit your like save files. If you want to have like certain things be like editable for like mods, you can prevent them from being encrypted. But if you need certain data to be encrypted, whether it's like kind of locally saved like file data that you might use for like Steam accounts or something like that, you should avoid doing that, but you might have to for like edge cases. It's better to encrypt it, stuff like that. So yeah, we're going to actually be going out how to do like an actual full-on save system, a modular save system that actually has backwards compatibility. So let's say you add a new line of data you want to save inside of your save files. we're going to be going over how to make it where you don't break your player save file. So while you're making your game and like releasing builds, I'll be showing you how to make it where you don't have to worry about messing with like older save files. Like you can literally like remove and add lines to your save file without breaking it. So we're going to be going over that. Do note, we're going to be, I got to rewrite some of this for CoreCLR. The save system, I mean, you can, this works by the way right now, like this does work in CoreCLR, but there's a couple of things that you do want to change if you want to do CoreCLR. I'll make sure to have those changed before the tutorial series is released for that video. But yeah, we got a lot more. We're going to be going over how to do like scheduling jobs by reference. We're going to talk about how to actually like use IJobForParallelForTransform. By the way, this is the secret sauce to some of my like math stuff for making sure like I can get like hundreds of thousands of enemies on screen without losing frames. We'll be going over how to create your own custom physics callbacks and a few other things. There's a lot here. There's a lot. There is quite a bit. But yeah. Man, we'll also be creating our own custom ability-based system. I'll be showing off how to do spawn patterns, so like you can actually do like a, I'm going to go ahead and like disable these spawn waves just for our sanity's sake. So if I actually go to shotgun pattern, I actually have it set as a circular spawn pattern. So if you notice, whenever I fire, okay, I shoot like 12 bullets. We're going to be going over different math algorithms to actually auto-calculate, depending on how many you want to spawn, like what like angle they spawn at. So if you do like 4, it shoots like the cross, like the normal directional. But if I do like something like 6, you notice that you also get like diagonal. So depending on like what amount you have, depends on like the spread and starting angle. Also, if I actually like enable this one enemy for testing, we'll also be going over targeting algorithms. So if you notice here, we have a red little orb and he just auto targets the closest enemy. And if I actually enable a second enemy here, so as I get closer to this one, it will literally auto target whichever one is closest. So we'll be doing proximity map algorithms to actually check to see which one is the closest, with burst compiling. That way we can get good performance. That way if you have like 100 enemies that are like within proximity, it won't like take forever to figure out like, okay, this is the closest one. So we're going to be doing that. And just for reference, it's not just like, okay, inside like game stuff. We're also going to be doing some editor tooling. Do not, I got to update some of these things because I was focusing on other stuff. So they may look very like basic at the current moment, but like I said, we'll be doing like a custom like editor. By the time the tutorial series reaches this point, I'll have this actually like reworked and looking a lot better because I got the modular property system working now. But we'll be going over like a character, like database editor, item editor, and also dialogue system. Yes, we're going to be creating a custom dialogue system. So if I actually like go into here and I actually go to my dialogues, I can actually create like conversations and so forth. So it's literally going to be recreating entire game mechanics. Vampire Survivors, Metroidvania, quest system dialogue, top-down ARPG. It is going to be a very long tutorial series. We're going to start with learning the stuff you need to understand to make the full games. So I'll be going over burst compilation, native collections, and like transform access rates, stuff like that first. Then we'll go into like the physics shape, physics bodies right afterwards. And then we'll go into, maybe if we have time, creating a custom sprite editor just for fun. So just so people know, yeah, you can write your own sprite editor and actually have stuff like that. And we can even go into creating our own custom like 2D lights. So for example, I'm not kidding, if I go to light here, go to, let's just add a random light. We'll be doing a God Ray system. So yeah, we're going to be doing God Rays, creating our own custom lights and actually learning how to inject that into Unity. We'll also be creating our own custom tile map editor as well. And do you know the tile map editor is going to be kind of later in the series because it's going to be a very insane tutorial series. For reference, inside the tutorial series, if I actually go here, I'm going to actually just find my refresh tiles thing. The tutorial series for like creating custom tile map editor and sprite editor, I'm actually going to teach you guys how to burst compile mono p invoke and multi-thread grabbing data from RAM addresses directly. Yeah, we're gonna have fun with this one. This is gonna be like the later series. We're gonna first make the entire Vampire Survivor game first, and then we're gonna be going into here. But we're also gonna be literally writing a multi-threaded and GPU, really like a compute shade GPU rendering tile map editor. For anybody that has never seen some of this stuff, I'm gonna make sure like during these videos people know some of this is unsafe. Some of my tutorials, you literally have to use unsafe command. Like if I actually go into my project, if I actually go into this, and I'll make sure to warn people like when you have to like enable this. If you don't want to, I'll separate my unsafe code stuff from my normal coding thing. That way people that are like, okay, they don't want to tempt it fate and accidentally mess something up. You know, like the worst you could do is literally crash Unity. I've only done, okay, this is going to sound horrifying. This was a bug and it was already fixed. I've actually found a way to actually blue screen Windows 10 using certain things. That was a bug, it was fixed. But unsafe code, yeah. So if you die, for those that like to not test fate, I understand if you guys want to skip that series, if you don't want to mess anything up. But for the most part, it's almost completely safe. The worst thing you could do is actually try to grab memory from address that's not valid from RAM, like directly from RAM, and Unity will close itself for safety. And you just got to reopen Unity. There won't be any corruption or anything. But yeah, so we're going to be literally learning how to grab native code, multi-threaded burst composite, grab raw data from a RAM address, and actually do it. And for people wondering, like the tile position, stuff like that, yeah, we're literally just grabbing tile position and tile data straight from RAM address using unsafe data. If anybody doesn't know what mono p invoke callback is, this actually allows you to call native code or code that's outside of Unity's engine. That includes C, C++. Like I could actually do a mono peak invoke callback, and I could literally call Windows operating system commands. Do you know, it's kind of, it's not like a full access. So if you're scared like somebody might try to do something to Unity project for hacking, they would have to be a very bad hacker, and it'd be very annoying to do it. But it is something that is possible. But Steam is really good about like catching games like that. Steam actually has an automatic system that will read data files to try to help find that. So yeah, we're gonna be going to some very advanced territory stuff. Like I'm not gonna say it's gonna end up being the most advanced tutorial series on YouTube for Unity, but it's gonna be up there because I mean we're gonna be doing multi-threading function pointers and stuff. And if anybody's wondering like why even bother doing this, there was a 12 times increase in performance for tile map on a tile sprite with 50,000 tiles spawned on the first frame of opening starting a scene. So for 50,000 tiles in one scene, I had a 12x, so 1,200% increase in performance. It is a huge performance difference. This is for advanced people or people that want to like be like, okay, I don't want to be a beginner. I want to get that higher pay, because this is, if you want to get like a higher paid position, if you want to get like that 6-figure plus paycheck, learning stuff like this really does help. It really does help. For reference, like if anybody's wondering, well, like I highly doubt I can get like 6-figure position just knowing mono p invoke callbacks and stuff like that. If we go into Unity's own code, let's actually go to game object here. And let's actually go, and you'll notice we have a use by native code and a lot of free function. Let's actually go inside game object. I might actually be inside the base object class. Yeah, okay. I kind of feared it might be inside the base object class. Actually, tile map and stuff like that might have it. But I was going to show like Unity themselves use free function pointers and mono p invoke to actually do stuff. With like the actual editor. That's actually how like some of the editors actually made, like the actual Unity editor. So if you can like learn how to do stuff like this, you could literally create your own plugins and stuff like that. Fun fact, oh man, I'm trying to remember the audio program. There's the audio program that's really popular with Unity. Oh my god. The audio, man, my brain went like completely blank on it. It's literally like an industry standard, like Fmod, sorry. That's what I was trying to. Fmod, the audio plugin, uses pinvoke to actually connect audio and stuff like behind the scenes. So like being able to do mono pinvoke and be able to do stuff like that, you can make plugins in C, C++. If you're a web developer, you could do like JavaScript with WebGL and WebGPU stuff. It's the intermediate. It's where you go from like some normal intermediate stuff to starting to get like higher intermediate, and you can get advanced stuff. And if you learn how to do stuff like this, it's easier to get a job. I'm going to tell you that. Easier to get a job with better base salary. For reference, Unity right now has a job position for like stuff like this. I'm going to actually open Discord. This is going to be the last thing, I swear, but this is relevant to tutorial series. If I actually go into like this, I believe, yeah, like learning how to do like mono pinvoke, learning how to do like direct calls to GPU commands and stuff. Unity even hires like people like that, and they offer base salary of, oh, I passed it. Yeah, that's the base salary. So, I mean, obviously you need to learn a lot more stuff like you need to know like how to actually do like GPU and rendering and like actually like render callback commands and like how to actually do a pipeline. But like this is kind of stuff that you get to the higher salaries, and like once you get into here, you have higher chances of getting to like higher paid studios. That's my done rant. So we're going to be doing intermediate to advanced tutorials. The aim is to be able to make advanced tutorials and like actually learn how to do advanced techniques and stuff like that. And hopefully without crashing Unity, because like I said, this is literally something that we're going to be like going into like the memory settings and so forth. It's going to be intermediate to advanced, and I don't want to rant anymore. I hope you guys look forward to it. There's so much here. There's so much. I'm very excited for this.